Hi everyone, welcome online. I am Shriharan and you're watching the video review of the transformer-less power supply. Now this is a circuit which is used to form DC voltage from 230 volts AC mains, and in this process we are not using any transformer. Now this circuit basically works on capacitive reduction of the AC and gradually forming DC using a bridge rectifier, then filtering the output using an electrolytic filter capacitor. So the other process remains the same, but only for the step down process we have just ignored the big bulky transformer and we're using a capacitor for that purpose. So let's go through the circuit, how the circuit works and what are the pros and cons of this circuit and what are the precautions you need to take. So I'll discuss all about them. So first up, some theory. Now as you can see that there is two mathematical formulas which are basically used in electronics as well as electrical engineering. Now you have one equation written over here. I'll show it with my tweezer, that Xc equals to 1 by omega c. Now this means Xc means the capacitive reactance, the reactance of a capacitor or the resistance of a capacitor, that's written as Xc. Now this is given by 1 by omega c. Now where omega means 2 pi f, 2 pi remains constant, value of pi is 22 by 7, and for your convenience you can take it as 3.14, where f is the frequency. Now this frequency means the frequency of the mains. So normally the frequency which you get at 230 volts, that is 50 hertz. So you need to multiply 2 into 3.14 into 50, so this will make 314, and I equals to V by Xc, where X is the reactance and this is the omega, and C will be the capacitance of the capacitor that is to be used for minimizing or reducing the magnitude of the AC to form DC. So this first equation, Xc equals to 1 by omega c, can be used to find or choose the value of the capacitor that is to be used to get desired amount of voltage and current at the output, and I is the equation to get the current, how much current you will get in the form of DC in the output. So that is given by V by Xc, where V is the voltage. Now V is the voltage, that is the AC voltage. Now in case if the AC voltage is 220, that is the standard voltage, now in that case the current will be a bit less. Now in case if the V increases to 240, which basically occurs at 3 AM and in fact at 4 AM at later in the night, you get voltage exceeding 230 volts. In that case the output current will also increase. So whenever you are selecting the circuit or you are implementing the circuit to drive some electronic circuit, you need to make sure that your circuit will withhold or your circuit is able to bear the maximum as well as minimum input voltage, because if the input AC voltage varies, the output current also varies, whereas this Xc, that is the reactance of the capacitor remains constant, as the only variation in the reactance of the capacitor comes when there is a variation in the frequency. But since frequency remains almost constant and that variation in frequency of AC supply is almost negligible, so in that case the value of Xc almost remains constant. So that's the theory part. Now let's go towards the practical understanding of this circuit. Now I'll just power off the circuit because I need to touch a few parts of this circuit, and I mind you that this circuit is connected to 230 volts AC. Now in case if I come into direct contact to that, could be lethal, because I'll be explaining and touching the parts with a tweezer, and most of the parts of this circuit, as you can see, is non-isolated. No isolator is placed, or no insulator is rather placed over them. So in case if I come into direct contact to it with my tweezer, which is metallic, it is a good conductor of electricity as well. So in that case it could be lethal. So I'll just power it off due to the safety reasons, and I'll go close to the circuit and explain every working of it. So here goes the power is off. Now as you can see that this circuit is fed from the AC. This is the red wire, which is the live wire, and this blue wire is your neutral wire, and this is doing the big job. This is your 0.47 microfarad capacitor, which is doing the job of reducing the magnitude of the AC, which is made and put to the one end of it. And mind you, this capacitor is a non-polarized capacitor, so you can connect it either way, so you don't need to worry much about it. And while connecting the circuit, it's not necessary that the phase has to come in through the capacitor. Even the neutral could be fed with the capacitor, and the phase could be fed through this 100 ohm 1 watt resistor. So polarity of connectivity is absolutely no problem in AC circuits. And below this capacitor, you'll find that here is a 470 ohm 0.5 watt 470 kilo ohm, sorry, 470 kilo ohm 0.5 watt resistor connected in parallel to this 0.47 microfarad capacitor. The purpose of connecting this resistor is to discharge this capacitor when the mains supply is missing, and this is called a bleeder capacitor. On the other side, you have a 100 ohm 1 watt resistor. Now one of the supply comes in, it goes through the capacitor. Now on the other end of the capacitor, the magnitude of the line decreases and it comes to the bridge, and the other side, the line comes after limiting through this resistor and enters the bridge rectifier. Now I'm using a 160 volts rated 10 microfarad electrolytic filter capacitor to filter the output from the bridge rectifier and to remove a decent amount of ripple from it. And this is my load. I'm just connecting an LED to the circuit. This is my LED, which is a green LED, and this is a 1 kilo ohm resistor which is connected in parallel to this 10 microfarad 160 volts electrolytic filter capacitor. And this is how the circuit works. Now there are a lot of precautions. There are basically two precautions, one for yourself and the other one for your circuit, and there are some pros and cons also. So let's start with the precautions. Now the main precaution that you have to take personally is make sure that when the circuit is powered on, you are not touching any part of the circuit, because of the simple reason that it is connected to 230 volts AC. Now coming into direct contact to that could be lethal, so that's your warning. You need to take care of that. The warning on behalf of the circuit is, whenever you are powering on the circuit, make sure that the circuit is connected with a load. Now when I say a load, this means either you connect a LED with a series voltage limiting resistor, or you are connected to the circuit which for which you have built this power supply, or you need to connect anything to this circuit, but make sure that you are not short-circuiting the polarities of the capacitor, and you're not short-circuiting the outputs of the circuit. And another thing is selection of the input voltage. Now I'll go close to the circuit and I'll show you the condition of this 100 ohm 1 watt resistor. You'll see that the resistor is a bit bulged up. Now this resistor is bulged up because when I built this circuit, I was feeding it to the output of an inverter which was built by Microtech. Now when I checked the AC output of the inverter, I found that it's 300 volts AC. Now that is the main reason why the resistance was getting extremely hot and deformation started to grow onto it. And otherwise, in case if this circuit is powered up to 240 volts AC, the circuit will work absolutely fine. There won't be any problem and any overheating issue with the resistors. And this is your bridge rectifier, which is made of 4IN4007 diodes, and this is how the circuit works. Now there are some pros and cons. That is, this circuit is extremely light and it's very cheap, and you can build this circuit on a very small piece of PCB, a dot matrix PCB, that is a printed circuit board, and you can save a lot of space, and you can design your circuit which requires very less amount of current. So in that case it's idle, because in any capacitive power supply the current is very low. Now this is a prime drawback. And another drawback is there is no AC and DC isolation. If either of the part from the AC section goes down, the high AC most probably will enter the DC section and thereafter destroy the complete circuit. So you have to do everything up to your own risk, but the circuit is reliable, and in most cases this sort of accident does not occur, but provided you have a very good luck, in that case nothing should happen and everything should work absolutely fine. So these are the pros and cons of the circuit and the warnings as well. And in case if you have any queries or doubts or suggestions, you can post them in the comment section below this video. And in case if you want to contact me regarding the circuit or any tips on electronics, you can always use the information provided at the end of this video, and my contact informations are also available in the description of the video, so you can pick them up from there as well. So once again, this is Shiharan. Thank you for watching.